Dear participants and our expert of the session, Engineer Sumit Kumar, Scientist SC, Punjab Remote Sensing Center, Ludhiana. Sir, welcome to you, sir. And thank you very much for finding time from your official hours to deliver the lecture. To all the participants, Engineer Sumit Kumar is working as a scientist in Punjab Remote Sensing Center, Ludhiana. Sir is BTech in Civil Engineering from Himachal Pradesh University. He has done his Master's MTech in Geomatics Engineering from IIT Roorkee. He is also pursuing his PhD from IIT Roorkee under Professor S.K. Ghosh. So, and Director Punjab Remote Sensing Center, Ludhiana. So, thank you very much, sir, for finding time, and I welcome you to the session for delivering your expertise in the field.
Thank you, sir, for the nice introduction. So myself, Sumit Kumar. So currently, I am working as a scientist in Punjab Remote Sensing Center. So in today's lecture, the topic was application of remote sensing data for the fire risk detection and analysis. As I think you know about what is remote sensing, what are different platforms are available, what are their resolutions, and what are the different applications of remote sensing data in the real life problems. So one of the major application of this remote sensing data is a fire risk, fire detection, and fire analysis. So as we all know that in the today's scenario in which climate change is affecting our lives, so one of the major indicator is a increase of carbon dioxide in the atmosphere. So there is a different and various sources from where the carbon is released, and one of the major source is the fire. And there are different kinds of fire, like there may be a natural fire, there may be a anthropogenically induced fire. So basically in this lecture, I will tell you about what are the various tools are available, what are the various satellites are available, what are the different kind of methods to analyze the fire and its detection and analysis. So as we know that the vegetation fire is a worldwide phenomenon, and consequences for the biosphere, atmosphere, climate change, and human health. It is estimated that the annual carbon emission on the Earth is estimated at 2.5 pg per year, and emission from the vegetation fire is a major source of atmospheric pollution. And enormous amount of trace gases and aerosols are injected into the atmosphere, affecting regional to the global climate. So going to my next slide. So here you can see that how different kind of spheres are there, like lithosphere, biosphere, atmosphere, and hydrosphere, and how fire is affecting all these spheres. Like in lithospheres, the fire is affecting the soil composition, erosion, landslide. Like when there is a fire in particular area or a forest, and what happened, the upper vegetation is removed by the fire, and that soil become more prone to the erosion and then further to the landslides. So this is a major effect of fire and smoke on the lithosphere. The second one is biosphere, in which life is there. So basically fire affects the health, loss of life, loss of property, and also the economic impacts of the fire and smoke. The third one is atmosphere. So for atmosphere, it is the major contribution. Fire is air quality and greenhouse gases. So as we know that due to the agriculture fire or vegetation, forest fire, or any other kind of fire, there is a huge carbon emission is emitted in the atmosphere in the form of carbon dioxide, methane, and nitrogen, and sulfur, and other trace gases. So it's badly affect the air quality and increase the greenhouse gases in the atmosphere. Then the last one is the hydrosphere. So basically, the effect of fire on the hydrosphere or water is the droughts, water quality, and flooding. So from where droughts comes? Basically, when there is a fire in a region, it is induced by a drought. If any region is facing drought, so the biomass will be more dry and it will have more impact on the fire, means the intensity of fire is increased. Then the water quality, if there is a fire on any area, so what happen, the due to the fire, the top soil means is burned. Then due to the raining or flooding, the nutrients flow with the water, which is holded by the vegetation. And when vegetation is burned, so all the nutrients and all the sodium, magnesium, and essential uh, uh, elements are gone with the water, and it also affects the water quality in the lakes and reservoirs. Then to the third slide, which is a type of fire. So basically, we classify the fire in two forms, like natural, and second is artificial or human induced. In natural fires like wildfire or peat fire, and the human induced fire is an agriculture fire. As the some of the research said that above 90 to 95% of fire, the main reason is anthropogenic. So means a lot of fire is induced by a human. Then and the type of fire like wildfire. So what does it burn? So basically in wildlife fire, so the burning of forests, shrubs, grass, it's contained. And in agriculture fire, the burning of crop, grasses, and shrubs is there. In the peat, like peat is a soil like material inside the top layer, so it also burn. So it is classified as a peat fire. So second one is when does it burn? So year round variable from year to year. Like wildfire, basically in Indian scenario, it is wildfire starts from the month of March, April, and rise in May and June. And in the US, the wildfire, basically you also heard about the California fire. So it is in the December or January month. And in Australia also, there's January to Feb, March, the main wildfire will be there. And in agriculture fire, because it is a seasonal type of fire, basically when the farmers want to clear their crops, so they burn their waste or residue. So it is a seasonal, like in India, there are two major seasons of agriculture fire. The first season is after the harvesting of wheat, so it is on April or May month. And the second one is the burning of rice residue, which comes in November month. And the peat fire is a seasonal variable from year to year. So the third classification is why did it burn. So basically wildfire, it is human induced or accidental fire, or maybe of natural or lightning. And agriculture fire, so it is a human burning prior to after growing season to clear the field crops. And the peat fire is a human cleaning land for crops, animal, and grazing. So for that, the peat fire will be there. And the intensity, like because wildfire contain more intensity, so the intensity is higher in the wildfire, and very lower intensity in the agriculture, and very low intensity in the peatland fire. So going to the next slide, so it is the climate and wildfire. So as fire reflects a complex connection between the weather and climate conditions and ecosystem process. Like if there is a rise in the temperature, so it creates a dry condition in forest, and which means increase or accelerate the fire. So there's a numerous studies that have indicated that fire frequency, spatial extent, and duration show a close association with climate variability. Like if the precipitation is low in any area, so it affects the fire frequency and spatial extent also. Like if there is a humid area, then it will be more less prone to the fires. If areas are dry, then it will be more prone to the fire. Like so climate plays a major role in the intensity and frequency of the fire and the spatial extent of the fire. Like it will be the means it will be contain very small area, or it will extend to a very large area. So like California fires are basically become more intense because of the climate induced variables. And the third one is the climate change along with the variability is also considered responsible for the increasing fire activity worldwide. And the increasing temperatures, because of increasing temperatures, the biomass is getting dry and it influences the fire activity. So this is the next slide. So climate variability and change and fire weather. So basically in this chart you can see that there is a classification of fire in term of the area and the time. So for a small area it's called flame, and the the variables are like oxygen, heat, and fuel. If there is a more oxygen, then it will be getting more fire, then fuel, and then heat. Then goes to the next one, which is a fire. So it's depend upon what is the weather, what is the amount, what is the type of fuel, and what is the topography of the area. So it's these are the major variables for a wildfire, and it's means the spatial extent will be in the kilometer square area. And going to the third classification, which is the fire regime. And basically fire regime, the major variables are like climate, what is the vegetation, what is the ignition. So it's calculated in decades. Like if we want to see what are the fire regime of India, so we have to analyze the data of 100 years, so to see what is type of climate is there, what is type of the vegetation is there, what are the ignition patterns, and what are the main sources which are which are responsible for the fire. So by computing that, then we are able to map the fire regime. Now the role of the fire in the environment. So in the role, basically fire it is divided into fire occurrence and the fire effects. So fires are the widespread seasonal events in many regions and around the world, and affect millions of hectares of the vegetated land every year. So from there are estimates from the satellite imagery that the total global burn area between 2000 to 2008 is ranged from the 330 to 431 million hectares of the area. And it is predicted that due to the climate change, there will be the increasing trends of the global fire activity leading to the increase in global burn area. So as we know that if the area or burn area is increasing, then there will be more emissions of carbon into the atmosphere, which will means replicate means it will put more carbon on the atmosphere and increase the rate of climate change. Then there are the effects of climate. So the positive effects of the climate is it helps to maintain the biodiversity, productivity, and recycling of nutrients. And fire may also be detrimental for the normal functioning of ecosystem. If it is excessive, because in a small amount it will basically contribute to a ecosystem. Like there are some small plants and some there are big plants. So what happens when there is a fire in particular area, so the canopy of the big plants will be burned, and it will give chance to the small plants to have a growth. So if there is no fire event, then there will be no very little amount of recycling of nutrients and biodiversity in the particular area. So in some cases, it is also helpful in biodiversity, but in very small area and in low intensity. If intensity is increased or the frequency is increased, then it is a detrimental to the environment. So the next slide is the biomass burning. So biomass burning effects can be observed to the local to the global scale. Now we can see there's a huge debate about the biomass burning. So because its impact the soil chemistry, surface runoff, land surface heat, and energy balance and air quality. Negative ecological effects may be result from biomass burning in non-fire adapted vegetation as consequences of altered fire regimes. If biomass burning is increased, so it's also changed the fire regime of a particular area. So in the map, you can see that what is the amount of biomass burning. So you can see there's a high amount of biomass burning in the African states and in the South American. Basically, it's cover the Amazon forest. So you can see that this area is more affected by the biomass burning. And these are the areas. Or in India, you can see the amount is low because basically in India the higher the main variable is agriculture burning, because we can see there are very means less than 30% of area is forest, and on that the major burning is happening in the northeast side and on the north side. In the the plateau, Deccan Plateau, and in the central forest in the Maharashtra, they are less prone to the fire because of low biomass and very less density of forest. So where density is high and the areas are dry, there possibility or probability of fires are more. The next is a fire and carbon cycling, because fire is also relates with the carbon cycles. So here we can see in the image the carbon cycle, like from the decaying it emits the carbon, respiration also emits the carbon, burning of fossil fuels also emit the carbon, and one of the major reason is the burning. So forest fire basically is a major source of CO2 emissions and agriculture residue burning comes in the second and contributes nearly 25% of total biomass burns. The next slide shows the fire risk mapping. So for mapping of fire, so there are a few variables like fuel type, fire risk, and fire regime and fire model. So basically, fuel is a physical characters of live and dead biomass that contributes to the spread, intensity, and severity of violent fire. So basically, it is a weight per unit area, and the second one is a fuel type. So it is a identifiable association of fuel element. So and size, arrangement, and continuity. So what is a fuel type means it is wood, or what is the type, and then is a fire risk. So this is the probability that a fire might start in certain area. Risk is determined by the compiling relevant factors that influence fire ignition and behavior. Like if there is a dry biomass, then the risk of the fire is more, and if the biomass is green or wet, so there is a less probability of a fire risk. Then the next important thing is a fire regime. So it is a temporal variability in the physical characteristics and subsequent effect of violent fire. So basically, a fire regime is usually defined in terms of fire frequency, severity, size, pattern. And the fire regime is a general description of the role of fire in a specific area and ecosystem. So it refers to the natural fire occurring over extended period of time. So the fire regime is basically when you have a data of extended period of time for a specific area. Then you see what is the fire frequency, means what is the frequency of fire, means after how much time the same area get fired and burned. And there the severity means how much severe is the fire is there, means if the severity is very low, we also see what is the amount of biomass is there. If the biomass is like forest, then the severity, we can say that will be more. And in the shrublands or grassland, the severity will be less. And then size and the pattern, means what are the patterns of fire. Then the last one is the fire model. So it is describe the potential of characteristics of fire. Then next is the landscape mining and monitoring. So for the
Sumit sir, sorry to interrupt you.
yes sir.
There are three red lines which have been marked maybe by mistake, which are
Okay,
appearing on the
let me
screen.
see. Sir,
So
it
if you
is.
can please, pardon?
Oh, I will check. I will.
These lines are there. It might be because of some of like tools might have been activated by mistake,
Okay,
and these three
okay,
lines
okay.
occurred. Yes, now they are not visible.
No.
Yes, yes, yes.
Okay, okay. Thank you, sir.
Okay, okay.
So now for mapping and monitoring of the fire, so there are some landscape variables. Uh, So the first is the vegetation moisture content, then vegetation structure, then topography, then vegetation type and extent, then vegetation stage and health. So first is a vegetation moisture content. So for it is very important to see what is the moisture in the soil or on in the vegetation. So it basically comes with the radar measurements or moisture indices. So we have a satellite data, so remote sensing data, in which we have a SWR band, SWIR band. So using the SWIR band and the NIR band, we can compute that what is the amount of moisture on the in the vegetation or in the biomass. And the radar also has been used to calculate the moisture content. Then second will be the vegetation structure. So what is the structure of vegetation? So it's come with the density and the height. So in this we compute what is the density of the forest. It is a high density forest, medium density forest, or lower density forest. And what is the height? Means it is a 10 meter, 20 meter, 30 meter height of trees or forest. Then the next is a topography, in which it's contain elevation, slope, aspect, and features. And the next is a vegetation type and extent. So it's contain what is a land cover classification, like what is a which type of forest is there, and means where is the shrubland, where are the means which are the shrublands, which is the grassland, what are the which are area which is forest. So it is also important indicator for mapping and monitoring of fire. Then the next is a fractional cover, means what is the amount of cover is there. Then the last one is the vegetation stage and health, means if the vegetation is in census or means it is dry, so it will be more means prone to the fire. And the next is the vegetation health indices. If the vegetation is healthy, so it will be green and it will be moist, so that will be less means the fire will be not that much intense for the healthy vegetation as compared to the weak or dry vegetation. So I will take one by one these variables. So the first one is the land cover classification and the fractional cover. So Basically, in the land cover classification, as you know, it is a grouping of spectrally similar pixels in remote sensing imagery. And based on the land cover classes, there are the forests, there are the shrublands, there are the agriculture areas. So here you can see this is a land cover classification layer of sub-Saharan Africa. So you can see that there are different type of classes that have been created, and there the tree cover, broadleaf, evergreen, deciduous, or the trees have 50% cover, the shrubland, evergreen shrubland, deciduous shrubland, greenland. So what is the bare land are there? What are the urban areas, and which areas come from the water bodies, and where areas or grasslands. So this kind of classification we need to analyze that which areas are will be more affected by the fire and which area will be less affected by the fire, because the vegetation basically tells what will be the fuel behavior. Like in the grasslands or shrubland, there will be less fuel available for the fire, and in the forest, because it contains more biomass and to sustain the burning, but the shrubland and vegetation often ignite easier. And basically, this classification of landscape differentiate between the fuel type and its spatial extent. Then the next is the fractional cover. So estimation of the portion of the area that is covered by each member of the different set of vegetation or land cover types. So basically, it calculated from the land cover classification, and it is useful for the classification to see that what is will be the fuel type. The next one is the vegetation moisture. So low moisture vegetation is more likely to ignite and contribute to the spread of fire. And dry vegetation can be influence the moisture content of the surrounding environment. So the absolute measurement of plant water content through fuel moisture content. So like fuel moisture content is a ratio of leaf water content and dry water content, and it is also quantified directly by the evapotranspiration. So basically, we compute the moisture content by using their several indices like ND, WI, ND, MI, and ESI. So these are the water index, dry matter index, and evaporative stress index. So by using our remote sensing imagery, and we can compute NDWI like using SWIR band, SWIR 1 minus SWIR 2, or SWIR 1 minus NDVI. So using the SWIR bands and the near infrared band, we can compute what is the amount of water is available on the biomass, and if there is a dry biomass, so what is the amount of dryness and the spatial extent. Then the radar remote sensing also provides the moisture content. The next one is a vegetation stage and health. So basically, unhealthy vegetation has a higher percentage of dead branches and leaves to provide easier burn fuel for the fire. So in the map, you can see that there's a days of year, and NDVI, which is vegetation index. So if the NDVI is increasing, then there will be more green biomass will be there, and if there is a less NDVI, then will be a low means moisture is there, and the trees or leaves are dry. So these dry leaves will be more affected by the fire. So there are different type of means analysis to see that how much amount of biomass is dry biomass, how much amount of the biomass is live or green biomass. So we conclude with this land surface phenology. So use satellites and sensors to track the seasonal pattern of variation of vegetated land surface. Like as we know in the Indian scenario, basically the trees become dry in the winter season. So and some of the trees gets dry in the summer season. So the trees which get dry in the summer season will be more affected by the fire. And for the monitoring of the stage and the health, so there are several indices, like I have just listed three indices, like NDVI, EVI, and SAVI. So basically, NDVI is normalized difference vegetation index, and EVI is enhanced vegetation index, SAVI is the soil adjusted vegetation index. So these are the different index. So, and there are some formulas for these index, and some bands they are using, from which these index are calculated, and using these indexes in time series manner, we can compute what is the phenology of a particular forest. And when the forest will be have a high NDVI value, then it will have more green, and when the value is low, then it will be dry forest. The now I am telling about the NDVI. So basically, NDVI is a metric for the vegetation health and phenology. So this is also very important indices in the remote sensing area. So basically, this NDVI is using for the monitoring of vegetation. So it tell about the greenness. Like in NDVI, basically we use the near infrared band and the red band. So basically, the red band, as you know, it is up to the 600 to 700 nanometer, and above that the region is NIR. So what happened in the red region, the trees or vegetations have a more absorption of the sunlight or energy, and it sent back very less amount of means energy, like only 10%. If it's contain 100 units of energy from the sun, then it only sent back 10 units of the energy in the red region. In the NIR region, because the energy is very high, so basically trees reflect back the energy up to the 70%. Means if it gain the 100 unit, then it will reflect back the 70% of the energy to the space. So using the difference, because only in vegetation the value of NIR is more and red band is less. So using this combination, so we derive a formula which is NDVI formula, like NIR minus red over NIR plus red. So the values come in the range of 0 minus 1 to 1. So value less than the negative value means there is no green leaves, and the higher the value, like to the positive one, so there will be more biomass in that particular area. So it is a very important or very major indices. Then the next one is the topography. So topography basically show that what is the elevation, slope, aspect, and canyon ridges, valves are there. So this is also a very important indicator for the fire mapping. Like if the slope is very high, or then that particular area will be more affected than the aspect. So if it is a south facing area, then there will be more cases that this region will be affected by more fire. Like this, the next slide, and this is a satellites and sensor for the vegetation based fire application. So here I have listed some of these sensors and their vegetation based fire application and their data products. So like Landsat is there, Sentinel is there, Modis is there, RIS is there, SMAP is there, EcoStress, SRTM, Sentinel, Los Pulsar. So these all sensor gives us a different kind of information. So some of are observing in the visible range, some are observing in the microwave range, and some are in the near infrared or thermal range. Like Landsat and Sentinel, these are basically used for the land class. Means land class is for land classification, land cover, land use, and they are also using for vegetation indices like NDVI, SAVI, and moisture like NDMI and NDWI. So MODIs, it is also used for the land class and vegetation indices. The data products are like imagery, NDVI, EVI. Then WIRS is also used for the vegetation indices. So the difference between the MODIs, WIRS, and Landsat Sentinels, because some like in Landsat you will get the data in near infrared, short wave infrared, thermal infrared, and optical vision also. But in Sentinel 2, the resolution is more, like it's contained the 10-meter resolution, and the revisit time is 5 days, but it doesn't contain the thermal band, and which is present in the Landsat. But now for the Landsat, as we know that Landsat 8 and 9 is operational. So now we have a revisit time of 7 days for the Landsat program also. Previously it was only after 15 days you will get the data of Landsat, but now with the operationalization of the Landsat 9, so now we have a data of after 8-day revisit or 7-day revisit, like in Sentinel it is 5 days. And the MODIs and WITs, basically they give the data, daily data, because they have a means wide swath of 2400 kilometers. Like in Landsat it is only 185 kilometer of swath, and for Sentinel 2 it is of 290 kilometer of swath, but MODIs and WITs are giving very wide swath of 2400 kilometers. Then the SMAM, this is a product, this satellites is a soil moisture active passive. So basically this is used for soil moisture. Then this is the next is the eco-stress sensor. Basically it is board on the ISS International Space Station. So it gives the thermal data and they give us the moisture and evaporative stresses. Then next is the Allos Pulsar, SRTM, and the Sentinel-1. So basically they all are used for the digital elevation model or synthetic aperture radar to know the topography and to know the moisture content of particular area. Now I am going to the remote sensing part. So the basic concepts of burn area mapping. So basically there are three basic concepts. So first is a spectral characterization of fire response. Second one is a remote sensing data for mapping burn areas. Then the spatial resolution of the satellite. I will go one by one. So first is a spectral characterization of the fire response. So the spectral separability between burn or unburn area is the strongest in the NIR and SWR region of the reflectance spectrum. So when we do the classification or we want to analyze a burn area, so we use the NIR and SWR band, because in the optical band the separability between the burn and unburn area is very low, but there is a very high separability in the near infrared and shortwave infrared to separate the burn or unburn area. Then the fire-induced spectral changes and the spectral signature of burnt areas. Then the spectral difference between the burn surface and other surface, and thereby creates a bias for detection algorithm. Like if there is a spectral difference, then it will be easy to classify or detect that which area is burn area, which area is not unburn area. So this graph we can see that it is showing basically three types. The first one is sensed vegetation, then green vegetation, then char, which is a burn area. So here we can see that the spectral response is increased. Like in the visible area, the difference between the green vegetation and burn area is very low, because in this region both are means absorbing the energy. But in the NIR region, so we can see that there is a sudden hike in the vegetation, because the reflectance of the energy in this particular area, but there is very low reflectance in the burned area. And then again you can see that in the burn area and the green vegetation, the difference is very high in the SWI region, and this is a sensitive vegetation. So you can see that in the NIR region and the SWI region, the separability is more, and particularly we also use this region for the classification of burn or unburn areas. So the next is the spatial resolution of the satellite. So spatial resolution between the size of it have a relationship between the size of burn scar and the spatial resolution of remote sensing data. So the estimation of the burn area improve as the resolution improves. So it's also depend that on what is our study area is there. So we are applying on global or regional or local level. Like if we want to analyze the fire pattern for the whole Earth, then we can use the MODIS or PIS data, but their spatial resolution is very close, like 500 meter by 500 meter. They have 1 pixel. And if we want to do some kind of regional kind of like for North India or southern India or Eastern India, then we can use the Landsat data which have 30-meter resolution. And if we just want to focus on a single state or a single district, so we have means data like Sentinel, which is giving the resolution of 10 meter. So as this study needs, like if it is a global study, then there is no need to use this Sentinel data, because it will have a huge amount of data and is very impossible to process all the data. And so for the global studies, we use some force resolution like MODIS. MODIS data is there and WITS data is there. So the spatial resolution is also an important indicator. So it depends what is our study area, what is the extent of our study area. So we are doing local kind of study or regional kind of study or global kind of study. Then the remote sensing data for mapping the burn area, basically there are different resolution, the temporal, the spatial and the spectral. So either we use a temporal resolution, either we use a spatial resolution, either we use a spectral resolution, or we can do the combination of these also. And the accuracy of these estimates will depend mainly upon the type of image. And basically for the fire discrimination, there are two categories, like monotemporal data or multi-temporal data. So in monotemporal data, we use a single image, and using the spectral signatures and the spatial extent, we do the classification. In the multi-temporal area, we take means two data sets, the post and pre data, means after before data of any kind of event. Because like if we have a wildfire on some area, so we will take the data means the previous data, and after the wildfire, and then we use some indices and find out which area is affected by the wildfire. Then there's another term called active fire detection. So there are two types of fires detection, like passive fire detection and active fire detection. In passive fire, we use particularly indices like NBR is there and DVI is there. In the active fire detections, the NASA have developed the algorithm. They are providing the active fire locations, means the areas where the fire is active. So active fire detection or hotspot detection is based on the detection of the TIR radiation emitted by the fire. Effective way to determine the seasonality, timing, interannual variation of fire. There are numerous air quality and carbon emission studies which use this active fire detection and to analyze what is amount of means carbon emission from particular area. So here you can see these are the active fire points in the Punjab due to the rice residue burning. So you can see these are the active fire points, and you can also see the smoke due to these burning. So this is example of active fire data. Then the next one is the passive. For the passive, there are different spectral indices like NBR. So NBR is a normalized burn ratio. So it uses the NIR and SWIR band. So it's because the reflectance is more in NIR and the reflectance is less in SWIR. So we use NIR minus SWIR over NIR plus SWIR. And this is also for the mono multi-temporal, we use NDY pre-fire minus NDY post-fire, like same for DNBR, to know what is the severity of the fire event. Then there is a SWIR index, which is a SWIR over NIR, and there's a burn area index also there, which is used to compute the burn area. For now, I'm going to tell you about how can we compute the carbon emission due to the biomass burning. As there's a biomass burning in an area, so how we can compute that what amount of biomass will be burned due to any kind of event. So it is basically there are four main components, which is modeling scale, biomass load, burning efficiency, and emission factor. So modeling scale as a biomass burning is a complex issue resulting from both natural and anthropogenic processes. This factor determine the fire occurrence and behavior can be viewed and approached at multiple temporal and spatial scales. So at the global scale, fire distribution follows similar spectral trends every year, and only during big events have enormous fire product spatial temporal distribution between the observed. And modeling the emission at this level is essential when working with the atmospheric models. So at the local scale, they have a cumulative and net effect in the global atmosphere on the medium and long term, which is caused by the regional climate characteristics and the destructive fire properties. So basically, to know what is the amount of emission, so there are three terms like BL, BE, and E. So BL is a biomass or fuel load, then BE is a burning efficiency, this is the amount of biomass burned, and then E is a trace gas release per unit dry matter, and MX is a unit area burn. If the unit area is burned, then how much emission will be there? So first is a biomass load. So first is the estimation that how much biomass load will be there. So the biomass load will be computed by using the land use land cover classification, in which we know that which area is a forested area, which is a shrubland area, which is a grassland area, and in forest also it is a low density forest, medium density forest, or low density forest. If density is high, then biomass will be high. And also we use the NDVI and NDVI to know the biomass load. So we know the tree cover, the fractional cover, the height, and canopy cover. So from these all variables, we know what is the biomass load per unit area. And the second one is the burning efficiency. So basically it is a direct function to total fine fuel flow like dead and live, and its moisture status. Like if the moisture will be more, then burning efficiency will be low, and if the vegetation is dry, then the efficiency of burning will be more. Means dry vegetation will be more affected by the fire. Then in the remote sensing, we use the moisture indices to know what is the amount of water, or we can also take some samples and know that what is the burning efficiency of a particular vegetation in the fire event. Then the last one is emission factor. So it is defined as the amount of certain trace gas species released per amount of fuel consumed. So there are very numerous studies in which they tell about the different vegetation and the different emission factors, like this amount of this vegetation will be burned, so how much amount of carbon is released, how much amount of methane is released, how much amount of sulfur, nitrogen, all these gases will be released. So from there we took the emission factor, and we compute what amount of carbon will be released by this. Now I am moving to the tools for the fire monitoring. So there are some tools, online tools are there available there, in which we can use for monitor the fire. So first one is a land fire fuels, fire regime, and topographic products. So there is a site. So I have given the link, so you can go there. They are providing what is the few models, canopy cover, height, intensity in a particular area, and basically this land cover they have only for the US they are giving. They also give the fire regime, means in fire regime they give what are the groups, what are the return intervals, vegetation conditions, and they are also providing the topography, elevation, slope, and aspect of a particular area in which you can, if you want to do some kind of analysis. So basically, only provide for USA. In for India, there is a portal called Bhuvan. So in Bhuvan, they are also providing the fire regime, but they are providing only for 1 to 3 years, and in land fire, they are providing for the various factor, like what are the fuel models, canopy cover, height, density, turn intervals, and also using the topography. The second one is the FARMS, which is a fire information for resource management system. So it is a very important tool. So basically, it was developed to provide a real-time active fire location to the natural resource manager. So if any kind of fire event will be happen, so by using the active fire data, you can see in the forms, like there are different options are available. Like if you want to see of today's, if 24 hours, 7 day, and you can customize that up to this day. If you zoom to a particular location, then it will tell that what is the amount of fire events occurred in that particular area. So this is also a very important tool, and you can also download the data of active fire components to see that what is the amount, or what is the occurrence, and what is the frequency of a particular fire events in a particular area. The next one is a Earth Engine app. So they also providing the live fuel moisture content. So you can compute the fuel moisture content on a particular area by using these Earth Engine apps. The next one is the Global Wildfire Information System, GWIS. So this system is also very important. Basically, it tell you about the global wildfire information, and also tell you about the amount of black carbon, carbon dioxide, sulfur dioxide, organic carbon emitted. And here you can see that I have taken the last 30 days data, means of January month. So you can see the fire events occurring in the northern India, and in particular in Pakistan, you can see there is green or yellow pixels. So it is showing that the amount of methane emitted in this particular area. So it shows that this particular area is affected by the fire, or it is maybe of agriculture fire or forest fire, and means this site will tell you about the active fire location, the burn areas, the fire emissions. Means it will give you all information regarding the fire event in any area in the globe. The next one is a GFED, which is a Global Fire Emission Database. So it has been used by the atmospheric and biochemical modeling group. So as an input data set, they use the Modis data. So they use Modis data for this for this GFED database. So basically, GFD also serve as a benchmark for optimizing fire modules in dynamic global vegetation and Earth system models for the fire emission estimate derived from the fire relative power. So finally, burn area from GFD has been provided by the mean of early warning system. So the first version of GFD was released in 2004, and there are several revisions has been done for the burn area estimates or carbon emission estimates. So this is the site of the GFED, in which you can see that what is in this particular image you will see that what is the amount of methane has been emitted in the last 1 month. So we can see that the Pakistan in the is affected. We can also see here this region. The Southeast Asia region is affected, and in South India, there are some parts which is affected by the fire. Means methane emission. Basically, they take the active fire location and burn area data they use, and from there they compute the amount of means amount of methane has been released in that particular area. You can also customize your study area, and there you will get the fire count, the fire occurrence, and you can also display the line chart, bar charts of analysis of any particular area. So this is also very helpful website and database. Now I am taking a case study to tell you about how we can use this fire emission database or data to know the fire behavior. So I have taken basically 3 objectives. So the objective was to study the fire trends and fire patterns in the Punjab. So the monthly and yearly trends of the crop residue burning has been studied, and district-wise analysis has been done. So as you know that the Punjab is located in the northern part of India. It's have a total geographical area of 15,000 square kilometers and lies between 74 to 77 east and 29 to 32 north. So it is contain fertile alluvium soil deposits, and the average elevation is 3 meters from mean sea level, and it's under the semi-arid region. And the maximum temperature is from May to June, and the lowest temperature in the winters in December to January. So for this study, the Modi's active standard active fire data has been used from 2003 to 2018. So this is our study area. So basically, the active fire product has been used, and yearly and monthly fire activity has been investigated for the 2 burning areas periods, which is the Rabi season and the Kharif season. So Rabi is from for the Rabi, the burning is happen in the April and May, and for Kharif, the burning is happen in the October and November. And I have also taken for the means for detailed analysis, I take 6 time periods to see what is the amount of shifting has been taken in the particular area. So the first is the temporal trend. So we can see that this is the temporal scan. The first is the annual, and the second one is Kharif, and in yellow one you can see this is the Rabi crop. So like in the this bar chart, you can see that most of the fire has been taken in the Kharif season, and very less amount of burning is happen in the Rabi. This is a monthly trend. So you can see in the May month and in the October November month, and the highest burning is high burning activity has been observed, and we can also see by year-wise analyzing that there is a decrease in the rice residue burning in the October month and increase in the November month. So in the Rabi, so in basically in mid October to November, the harvesting has been carried. So residue burning mainly carried in the harvesting of the crop was last week of April and May for the Kharif. and this is the I have taken the data of April and May, which are the main fire season, and October and November, and it is observed that the trend of burning has been decreased in the October month, and the trend of burning has been increased in the November month. So and the maximum burning has been means observed in the October month is from 2003 to 2008, and the maximum burning has been observed in November month from 2011 to the present. So then I have taken the time frame. So you can see this bar chart shows that what is the amount of burning in these 6 time frames, like from October 1 to October 10, then 11 to 20 October, 21 to 31st October, November 1st to November 10, then November 11 to November 12. So we can see that the trend is decreasing. Like in the first in the October month, the highest burning is means occurring, but now in the present scenario, the highest burning is taken in the October 21st to the November 10th. Previously, the highest burning was from October 1st to October 20th. So there's a shifting has been seen or observed in this particular data. Then the district-wise average activity of fire count was also observed, and it is observed that the Sangrur, Ludhiana, and Firozpur district of the Punjab has the highest active fire spots, and in Pathankot and SAS Nagar, Mohali, the lowest the fire activity has been detected. And this graph shows the spatio-temporal district-wise analysis that how much burning percentage is there. Like in Ludhiana, Sangrur, the burning is high, and in Hoshiarpur, Gurdaspur, and Amritsar, the burning is low. So basically, one is showing the Kharif, and second one is showing of the Rabi. So for Rabi, basically the Firozpur, Tarantar, and Gurdaspur, and Amritsar are having high wheat residue burning, but for rice residue burning, Sangrur, Ludhiana, Moga have highest. This shows the same thing that in Kharif, which districts have more contribution, and Rabi, which district have more contribution. So basically, what is happening with this, as because we can see there is a shifting of biomass burning or crop residue burning, the region is experiencing more accumulation of air pollutants because of decreasing of temperature. So as we know, in the November month, the news came that there is very worst air quality in the IGP, Indo-Gangetic Plain, or in Delhi NCR. So the main reason is due to the shifting of this burning season. That if because it is shifted to the more because of this shifting in the winters, so the air pollutants get accumulated in the lower Earth atmosphere, and there is a rise in the pollutants in the atmosphere, and which decreases the air quality. The second study I have taken, which was a Modi's-based spatio-temporal assessment of agriculture residue burning in Madhya Pradesh. So it was published in Ecological Indicator, and Verma et al. I have taken a research article. So in that article, the objective is to quantify the spatio-temporal patterns of agriculture residue burning and monthly and season patterns. So the Madhya Pradesh was selected. So here you can see the land use land cover map of Madhya Pradesh, and active fire data they have also used for the analysis. And basically they analyze the cropland burning and then do the then cluster analysis to see that which areas are more affected by the fire. So K-mean clustering they have used. So the results was in 2002, only 1268 fire events was there, but it has been increasing for 7915 in 2006. And the spatial density of Modi's fire count was 7.5 fires per 1000 square kilometer, which is increased to 46.9. So that exhibit that there is an increase in the fire. And basically the cropland fire, which is accounted for 48.1% of total fire in the 15 year study area. So these are the results. Here we can see that what are the more major clusters of the fire. And this is a monthly analysis. So in Madhya Pradesh, you can see the high fire activities in April. So because of the wheat residue. So in Punjab, the residue burning, the fuel type is same, like vegetation burning or agriculture burning is agriculture residue burning is there, but the temporal scale is different. Like in Punjab, the highest burning is happening in November. In Madhya Pradesh, it is happening in April, and in November there is very low fire activity in Madhya Pradesh. And these are the results. So they said that the annual rate of 64% has been increased, and there's a tenfold increase from of agriculture residue burning from 2002 to 2016, and the high fire count was detected in cropland, which contributes the 54.5 as compared to the other land use land cover. And highest active fire proportions were in the month of April, followed by May, and then March 8.9%. So these are the active fire locations from 2002 to 2016. So thank you.
Thank you very much, Sumitji. Deepa is having one question.
Okay.
Deepa ji, if you can switch on your mic, you can ask yourself. Suguji is thanking you for nice presentation.
Thank you.
Deepa ji, can you switch on your mic?
Hello, am I
Yeah,
audible,
yes,
sir?
Deepa ji. Yes, Deepa ji.
Yes.
Okay, sir. How accuracy we can find the data like inflammability index or velocity or the direction of wind at the time of fire in the forest by using the remote sensing?
And basically for the remote sensing, you will have the land cover information, the moisture, and all this means what is the canopy cover, what is the fractional cover. But I am not sure with the wind speed accuracy about the wind speeds. So I think because basically for wind speeds they use a radar data to compute the wind speeds. So I'm not that much confident because I have not used the data because
Okay.
we only use the land cover data and know what is the amount of forest is there, what is the amount of moisture is there. So I will see and tell you about what is the accuracy about wind speeds. Means, but this is also a major variable. So if wind speed is more, then the intensity will also increase.
Okay, sir. Okay, got it, sir. Thank you.
Okay, thank you. मनोज सर आपका म्यूट है माइक.
Yeah. Thank you very much, Sumit, for delivering this expert lecture on this very important topic, because as soon as Delhi gets chalked, people from Haryana and Punjab, or the farmers from Haryana and Punjab, are getting these kind of threats, that because of this forest fire burning in agricultural fields, it has become evident that this should be stopped. and there should be,
Yes.
we should find some alternative technique. And apart from stopping by the time these techniques are developed, we should start, let's say, by punishing people, or these kind of techniques have been identified to specifically mark these agricultural farm
Yes.
fires
Yes.
to the ground. So
Yes.
it helps various decision makers, specifically for the district commissioners and DMs, to specifically locate those farm fires and try to, let's say, extinguish them. So
Yeah, yes,
thank you
yes,
very much, Sumit, for speaking on such an important topic. And we are
Okay,
highly
okay.
obliged for your timely help and remaining available for the two alternative sessions where Professor Garg was not sure of delivering his lecture. So thank you very much for remaining available for both the sessions. Thank you very much, Sumit.
Thank you so much, sir. Thank you.
Okay. Thank you very much for the time also. Like we planned it up to 2:30 only. So thank you very much.
Okay, thank you, sir.
Okay. See you, Sumit, sir.
Okay, sir. Thank you.
Okay. To all the participants, like the discussion is going on regarding the final session. Engineer Sumit has already delivered the final technical session, but will require one valedictory session also from the purpose of AICT also, and from the purpose of our university also. So I request you all to kindly switch on your videos. I request you all to kindly switch on your videos, because I have to take photograph of the valedictory session. Mohan Vishal Gupta sir, kindly बैठ जाइए sir थोड़ा सा.
Hello, sir.
Hello, it's good to see you all, and I hope I disturbed you a lot during all these sessions. So as a, let's say, coordinator, it was my duty also to regularly invoke you to participate, because at the times when these speakers keep on speaking and we don't find participants to respond back, it becomes very difficult. So I'm really sorry if I have spoken anything wrong to any one of you, although I take care of the things that I should remain within the limits. I'm not sure how to change these slides. Suguji, Suhashni ji, I'm unable to see your videos. All the participants are requested to kindly switch on your videos. Any feedback that you guys want to put upon, that I should take care in the future FDPs, you all are most welcome. This time there were some difficulties, like one of the speaker expired, one of the speakers relative expired, so I had to keep on changing the speakers also, and up to last moment I couldn't finalize. So Sumit was an alternative to one speaker, Professor RK Professor RD Garg from IIT Roorkee. So because sir was not sure of, Kiran ji, Dr. Kiran.
Yes, sir, you have clicked on. I cannot show my video.
Ma'am,
It is showing host setting.
I have allowed participants for all the settings.
It is showing you cannot start your video because host has stopped it.
Ma'am, others can do it. I have, as a host, I have allowed everyone to show the video. If it's possible, kindly check at your system level.
Okay, sir. Should I send a screenshot what it is showing? You cannot start your video because host has stopped it.
Ma'am, I have to click few of the screenshots of my, I wasn't allowed through.
It doesn't
my
matter,
mobile
sir.
phone.
It's okay. It's okay, sir.
I have to click some of the screenshots of these participants. So I requested you all to switch on your videos. Kindly wait for a few more minutes. I'll click 2-3 more pictures. regarding the test that we are supposed to conduct at 5, there is a view of some of the participants that we should conduct it at 7, because some of the participants might be traveling from their colleges to home or from their offices to home during this period. So if everyone allows, kindly, can we schedule it at, let's say, maybe 7?
Okay, sir.
Or another thing,
Okay, sir.
or another thing can be like, we can start the test and let's see if how many people can do it. I'll register the time from the time that you'll open the sheet and from the time that you'll submit it. That I can register.
Yeah, we can start the test now as per the schedule.
As per the schedule also we can start, or we can do it at 7 also. I don't have any problem, because I have to compile all the attendance also. That will also take time. So tomorrow I'll be compiling it, and by the end of, let's say, tomorrow evening or maybe day after tomorrow morning, I'll submit all the attendance and marks to AICT portal, and then after that you can fill the feedback form and can
If
download your.
possible, take on the schedule time. If possible, take on
Okay.
the schedule time. That's
Okay.
good.
Okay, then we'll take it at schedule time. How many participants are there who cannot do it at 5?
Sir, 5 is not possible.
I'll see the chat. I'll see the chat if there are 2, 3, 4, 5, 6, 7. There are more than 25 participants who are saying they agree upon 7. Please allow me to join. Oh, more than that. Now, because I have to allow the speakers also, speaker of the valedictory session. So I may not admit you now, the new people. Some of the people have raised hand. Okay, they have raised hand for the saying of 7. What I'll do, I'll keep the test open up to 7:30. Ashish Tamrakar ji, is it okay?
Yes, it's okay, sir.
If what I'll do, I'll start the test at 5. I'll share the link at 5, and then we'll keep it open up to 7:45.
Yeah,
That
that's
will
a good
resolve,
idea.
that will resolve the problem of both.
Good, sir. That's
Right,
good.
right. So it can accept responses till 7:30
Till
or
7:45. Till 7:45.
Yes.
Yes, sir. It's
I hope that will resolve
Thank you.
the issues of both the people who are traveling and who doesn't want to skip it from time.
Right, right.
So to all the people who are, let's say, any feedback for the future FDPs? Shashi Bhushan Maharana ji.
Yes, actually, I'm from computer science.
Okay.
Upon my strong interest, I actually joined. So it could be one motivation for me to explore further, because everything nowadays is cross disciplinary. So we cannot confine in our own domain, right? So that was quite interesting. But what I felt lacking here, I mean, don't take me wrong.
Yeah. Please.
I was expecting some sort of hands-on, right? So I can actually get some good start off. So it was completely missing in this 5 days.
Sir, actually the thing was, it was planned in the physical mode. That's why these days now, it is not starting from Monday. It was planned in the physical mode. So it was starting on Thursday, so that people who can get 2 days leave from their institute also. So within 2 days leave, they can come here at Murthal and can do the hands-on. But by AICT, it was forced upon us that we should get this from offline to online mode. So that's where the problem occurred. Otherwise, it was planned in that manner only, that all the afternoon sessions will be hands-on. There would have been 5 hands-on sessions.
Yeah, but we could have conducted practice session online also. I mean, we could have.
Sir, in the first FDP of mine, I was allocated 2 FDPs by AICT.
Right.
So in the first FDP, we tried it, but we couldn't succeed because most of the participants were not responding back. That's where the problem was. When let's say this grasshopper thing, it was planned in physical mode only, because the speaker was supposed to travel to India. So it was supposed to be in physical mode, and he shared the files with me. But from the first 3 days, when none of the participant was responding back even to the questions by the speakers, it became difficult for us also. Next time I'll
But
take care.
the
Even if the
reality is
participant,
in any FDP, there will be 20 to 25% responses you will get, really. But there are a lot of background issues, like people get it recorded, so in their convenient time they will look at it back. So
okay,
there are a lot of issues. So we cannot,
I'll then preferably do. See, our university has been allocated in Atal Center. So our university will be organizing almost more than 50 FDPs in a year every year. So from next time onwards, what we'll do is we will try to go with the hands-on session. That will be a better approach. I strongly agree with you, but due to this online processing, it is difficult.
okay.
I also strongly agree, Dr. Mahendran, which has written the excellent session, sir, but the sessions may not be conducted on Sundays. I strongly agree. Next time onwards, I'll prefer no Sunday or Saturday exercise, because I also had to sit at office and my kids were also waiting at home. So for you also, the similar kind of exercises might have been occurred, and you were also facing the similar kind of problems at your home. So anyone else who wants to give any feedback? Thank you, Shashi Bhushan ji. Thank you very much.
Yeah, thank you also, and all the participants also, because their interventions also make us learn more, because I am quite naive. I have to explore a lot to understand. So,
And a special thanks to Manoj sir.
Sir,
And
thank
nice
you, Ashish
conduction
ji.
of
Thank you very
program,
much.
sir. Nice conduction from your side, sir. Nice
Thank you,
cooperation,
sir. Thank you very much.
Thank you.
To all the participants, those who are leaving the room, I won't be able to admit you back because of my restriction that I have to admit all the invited speakers and the department chairperson, then vice chancellor sir, even council president, our worthy registrar sir, all these people. So I won't be able to admit you back. So either
Manoj,
kindly
sir,
don't leave.
yeah, one more thing.
Yes, sir.
What I being from CS, I can a little bit suggest this. This 100 bottleneck should not be there.
Sir,
So
that
there
was
are a
the
lot of
limitation.
confusion, right? First
Sir,
come,
yes,
first
yes.
basis.
It-
So you
sir,
can
it-
organize it on WebEx or any pro edition, not a free edition of Zoom. So it is
Sir,
restricting
Sir,
100.
it's not free edition of Zoom. Our university has purchased it, but for purchasing it in one session, because we have gone with the WebEx now. So WebEx, we are having some 1,000 participation allowed.
Yes, yes, yes.
But there is a problem in WebEx that while joining, lot of participants face lot of difficulties if they are not having WebEx accounts. So there lies the problem.
Okay, please explore it, because splitting
yes, sir,
participant
sure,
over
sure.
YouTube and here
Sure.
causes
Sure,
issue.
sir.
Yeah.
And
Okay.
this was the last FDP in the financial year, so our university
Yes,
opposed it
2022.
that we shouldn't go with another, let's say, more than some 18,000 rupees were to be invested. So the university thought of, let's not go with that. So that was the problem. I strongly agree with you that it should have been more.
Yes. So should we leave so other people can join in this meeting?
No, there is a room. My dean, faculty of architecture, urban and town planning, Professor Ajay Munga has joined. He has helped us a lot during the planning phase of this FDPs and during the conduction of the FDP also. So he has remained very instrumental in this. So Ajay sir, I welcome you and thank you very much for joining well in time, sir. You can switch off your videos if you want. I have clicked you can turn off your videos. I'm very thankful to all the participants who remain very patient, but I request you all to kindly remain engaged in all the discussions that the experts want. I'll surely share the email IDs of all the speakers so that they can you can always remain in contact with them. Sneh, are you there? Thank you very much, ma'am. Thank you very much. There were 5 FDPs to all the participants. There were 5 FDPs this AICT has allowed to our institute, and 2 were allocated to me. So I feel privileged in telling that I got 200 applications for both the courses, and apart from those 200 applications, I could, people responded back and sent me a mail saying that we want to register. So in first FDP, I could get more than 50 mails, and in second FDP also, I could get more than 30 emails people who wanted to register. So I am very thankful to all the participants and for this particular. Thank you very much, everyone, for making so nice comments. And yes, the test will be very basic and will be very helpful in knowing all the participants from different branches, different domains of or disciplines will be able to attempt it. Those who have listened to the speakers, they'll be very easily able to do it. I'll share the link at 5 and you can continue up to 7:45 so that all the participants can be accommodated. Those who will be traveling during this period also, they can start attempting at 7. So your time will be registered from time of attending and time of submission. So you are all are requested to kindly remain keep patience. By the time all our dignitaries will join, they all are very punctual to time and they'll join within in time, well in time rather than saying on time. Because of the over meeting, if somebody won't be able to join, I'm pasting you the streaming link of YouTube channel. So The valedictory session can be, let's say, viewed on that also.